find the rule for the patterns. So there's an investigation in your book, and it's on page 102, and you guys can just scratch out these answers real quickly. So I think the investigation is too easy for you, so I'm changing the investigation, so I actually don't want you to look at your book, so close it. But later, you can read page 102, because they have too many answers for you. It's more like a beginning thing. But I mean, you guys can see the pattern here, right? This is going to be what? -1, 0, 1, 2, 3. Okay, so that's not interesting for you guys. What's interesting is how do you write the rule? Okay, so he says it's n-5, right? And I bet you guys agree with that, right? Yep. Pretty easy. You're taking the number up here and you're subtracting 5 to get the number down there. So that's a super easy pattern, which is why they started with it. Okay? I also want you to look at what's going on here. We are adding 1 each time. And as the chapter gets more difficult, all of these little easy skills help you solve problems that are much more difficult. So we want to make sure that we see some relationships. Okay? So now, what is, yeah, because this is, you're going up by how much here? 4. 4, so you're adding 4. So you see the pattern, that's easy. So this is going to be 13, 17, 21, 25, 29. But somebody said n+4. Do you guys agree with that?
No.
No. Okay. So think about it a little bit harder. The reason it's not n+4 is because this is the n value, for example, 7. 7 plus 4 would be 11. That's why n+4 doesn't work, in case you were wondering why n+4 doesn't work. But the 4 has something to do with it. So I want to show you, like if I were going to plot some points, just think about this algebraically. If this were like your x up here, your input, and that's your y, it would go through the point 1, 1, and then 2, 5, which would be a little higher up. So like right here. And then it would go through 3, 9, so that's 5, 6, 7, 8, 9. What shape is this going to make? A line. Brad?
Is it 4n minus 1?
Yes, because the slope is 4. Right? If you think about this line here, the board has been behaving poorly, so let's see if I can.
Well, what about number 1?
Well, hold on. Oh, let's finish. Let's continue with this before we go farther. So the line looks something like that, right? It's a sketch. And then I'll talk about number 1. But now, if I look at the slope here, it was up 4 over 1. Do you see that? Catherine? Oh, it might be minus something else. I was only listening to the 4n. Sorry. What did you say, 4n?
You said the correct answer.
I said correct answer, and
I was like thinking the right thing, but said the wrong thing.
Okay, and I was listening not very carefully. Good job. The two of you make a perfect person. There you go. So this is 4. Okay, and you can tell it's, if you did algebra, you would have thought of y equals mx plus b, right? And you can tell the m is 4 the way I wrote this. And you know the b is negative. Okay? So here's how I do it without a graph, because taking the graph method is nice, but it's slow. So what I do to check your work is I say, well, I'm going to test it with 2. 4 times 2 is what? But I need to get all the way down to 5. What do I have to do? Minus 3. Okay. What's 4 times 4?
16.
If I subtract 3, does it work?
Yeah.
Yes. So that's how I do it without the picture. And actually, it's a great skill because you don't really want to take the time, Jack. Jack, I'm now recording me disciplining you. What are you doing there? Focus. Focus, Jack. So the idea is not to have to draw the picture, to be skilled enough to not draw the picture. Do the next one on your clear view. I will. Catherine, what'd you do? What'd you get? Okay. Boys, did you hear what she said? Negative 2n plus 5. So why would you have that answer? Tell us your steps.
So first, I figure out how much from 3 to 1 is, and then 1 to negative 1 is.
And so, in other words, to get from 3 to 1, you have to drop 2. To get from 1 to negative 1, you have to drop 2. So you would have to keep dropping 2 here. And anytime the number is the same, you have what we would call a linear pattern. Up here, just to tie this in, we had to go up 4. That 4 tied into the equation. Did you see that? So the negative 2 here is going to be the first part of the equation. Does that help? So then you're going to test it.
Is that always true?
If it's linear, so it's linear whenever the number never changes, where we say it's a constant increase. The first difference, the first time you take a difference between the left number and the right number, if it's always the same number, we say the first difference is constant. I'll give you examples where the first difference isn't constant, and then it's more complicated. But we want to start with the basics so we understand it. So I'm going to take the negative 2, and I'm going to multiply it by, I'm going to pick 5 for my n value. Negative 2 times 5 is negative 10. But I need to get to negative 5. So I have to add 5 to get to the right answer. So like here, negative 2 times 1 is negative 2. But if I add 5 to negative 2, I get positive 3. Raise your hand if that makes sense. Better? You know the next one. That's progress.
I know the next one.
Okay, Thomas. So the process, what's the first difference? Right.
Minus 2.
So these are an increase of 3, right? So I mean, this is easy. That part's not very interesting. 3n, because 3 times 2 is 6. And we need to get to 4, so we have to subtract 2. So she was right, and he is right. Get it? Okay. The next answer is shown. Darn it. Okay. That's enough. All right. Raise your hand if that makes sense. Abby, it looks like, am I blocking? I'll post them too. Okay?